Hey guys, I'm continuing straight on from the previous video. So we're now up to finding the centroid y, bx dash, and ix dash. So we know that the formula for the centroid yc is bx on a. We found bx though to be 0. So the y centroid, the distance to the y centroid is just going to be 0. And you can see for our problem that sort of makes sense. Because it's symmetrical up and below, the centroid for the y is just going to start at y equals 0. Okay? And that actually makes things quite simple. You'll see why now. So continuing on, bx dash is always 0. The first moment of area from the centroidal axis is always 0. So that's easy. The next thing we need to do though is find ix dash. Ix dash is the integral over a of y dash squared dA. So we need to come up with a formula now for y dash. From the previous videos, we have a formula for y. So f1 of x and f2 of x. We need to come up with a similar formula for y dash now. Now, because the centroid starts at the same place, so because the reference axis goes up from y and down from y, and the centroidal axis also goes up from y and down from y, we can say that y actually equals y dash. Okay, so there's in the stripes video, if you watch that, strips video, sorry, we had a formula like y equals yc plus y dash. Okay, so we're using the same thing, but in our case, yc is 0, which means y equals y dash. Okay, which makes things very simple, because that means that f1 of x dash, or y dash, equals f1 of x dash, which equals hx dash on a. Similarly, y dash equals f2 of x dash, which equals minus hx dash on a. So that makes it very simple. So watch this. We're going to be going ix dash equals the integral from 0 to a of minus hx dash on a, hx dash on a, for y dash squared dy dx. Okay, so this is just using the same notation over here, except now we're doing it for h dash. So y dash and y dash for function 1 and function 2. So if we were to do this, integrating for y dash squared over dy. So first of all, we're just going to put the outer integrals on the outside. So we would have y dash cubed on 3 from minus hx dash on a, hx dash on a. So solving this, we would have h cubed, x dash cubed on 3a cubed. This is going to be minus, then the minus cubed will give us another minus, so minus h cubed, x dash cubed on 3a cubed from 0 to a of dx, which, so this would be that plus that. I'm just going to put all the constants on the outside, so we're going to have 2h cubed on 3a cubed outside of x dash to the power of 4 on 4 from 0 to a. Solving this, 2h cubed on 3a cubed outside of a to the power of 4 on 4 minus 0. And if we were to simplify this, we would get ah cubed on 6. Okay, which in actual fact should be the same as our ix value, because our centroid starts at the same place, and we can see that in fact it is, that ix equals ix dash, ah cubed on 6. And the reason is because our centroidal axis and our reference axis are both starting at the same point. Anyway guys, in the next video we're going to go on and find the other things we need to look at. So I guess we'll see you there guys, I hope that helps.